Welcome to Circuits Analytica. In this video, we will discuss binary to decimal number conversion. Conversion of binary numbers to decimal numbers. The column weights of binary numbers are powers of 2 that increase from right to left, beginning with 2 raised to 0 is equal to 1, 2 raised to 1 is equal to 2, 2 raised to 2 is equal to 4, etc. The column weight of the least significant bit is 2 raised to 0 is equal to 1, and column weight or column value of next significant bit is 2 raised to 1 is equal to 2, and so on. The decimal equivalent of a binary number can be calculated by adding the column weight or column values of all bits of the binary number which are 1. Let P is the decimal number whose binary equivalent is given as Bn, Bn-1, Bn-2, etc., B2, B1 and B0. So the decimal number P can be written as P is equal to Bn into 2 raised to n plus Bn-1 into 2 raised to n-1 plus etc. plus B2 into 2 square plus B1 into 2 raised to 1 plus B0 into 2 raised to 0, where 2 raised to n, 2 raised to n-1, etc., 2 raised to 1 and 2 raised to 0 are the column weight of the bits Bn, Bn-1, etc., B1 and B0 respectively. So this is the table using which we can convert the binary number to decimal number. The first row in the table represents the binary bits like B3, B2, B1, B0. Then the second row represents the binary number. Then the third row is for column weight of the binary number as powers of 2. And finally, the last row is the column weight in decimal value. We will be filling these rows one after the other. After filling the fourth row, we will add the numbers in fourth row to find the decimal number P. First problem, find the decimal equivalent of binary number 0, 1, 1, 0. First step is to write down the binary number. So here the binary number is 0, 1, 1, 0. Next step is to fill the third row, the column weight in the form of power of 2. So here as B3 and B0 bits are zeros, corresponding cells of the third row are filled with 0, and as B2 and B1 are 1, corresponding cells in the third row are filled with 2 raised to 2 and 2 raised to 1 respectively. Finally, let us fill the last row. As B3 is equal to B0 is equal to 0, corresponding cells in the last row is filled with 0. As B2 is equal to 2 square and B1 is equal to 2 raised to 1, the corresponding cells are filled with 4 and 2 respectively. So after filling the fourth row, we have to find the sum of elements in the fourth row. That means the decimal equivalent is 0 plus 4 plus 2 plus 0. So we will get the decimal equivalent as 6. Second problem. Find the decimal equivalent of binary number 1000. So as the first step, second row is filled. The binary number 1000 is filled in the B3, B2, B1 and B0 cells of the second row. Next step is to fill the column weights as power of 2 in the third row. So here B3 is equal to 1 and rest of bits are zeros. So the third row is filled with 2 raised to 3. Remaining 3 cells are filled with zeros. Finally, in the fourth row, the decimal value of the column weights of various bits are entered. Let us find sum of the elements in fourth row. 8 plus 0 plus 0 plus 0. We will get 8 as the decimal number. Problem 3. Find the decimal equivalent of the binary number 11001. First step is to enter the binary number 11001. Next step is to enter the column weight as power of 2. So the column weights are entered as 2 raised to 4, 2 raised to 3, 0, 0 and 2 raised to 0 for bits B4, B3, B2, B1 and B0 respectively. As the next step, let us write the decimal equivalent of powers of 2. So 16, 8, 0, 0 and 1 are entered. Next step is to find the sum of elements in the fourth row. 16 plus 8 plus 0 plus 0 plus 1 gives us 25. So decimal equivalent of 11001 is 25. Fourth problem. Find the decimal equivalent of binary number 101010. First step is to enter the binary number 101010. Next step is to enter the column weight as power of 2. So column weights are entered in the third row as power of 2. 2 raised to 5, 0, 2 raised to 3, 0, 2 raised to 1, 0. For bits B5, B4, B3, B2, B1 and B0 respectively. In the fourth row, we have to enter the column weight as decimal values. So 32, 0, 8, 0, 2 and 0 are entered. So wherever there is a 1, we have to enter the column weight, and wherever there is a 0, simply put 0. Now as the next step, we have to add the elements in the fourth row. So we will get 32 plus 8 plus 2 is equal to 42. So decimal equivalent of the binary number 101010 is 42. Find the decimal equivalent of the binary number 1100100. In the second row, enter the binary number as 1100100. After that, write the column weight as power of 2 in those cells where there is 1, and wherever there is a 0, simply put 0 as the column weight. So as B6, B5 and B2 are 1, the column weights are entered as 2 raised to 6, 2 raised to 5 and 2 raised to 2, and the rest of the columns are filled with zeros. Next step is to enter the column weight as decimal values. So the column weights are entered as decimal values. So wherever there is 1, we have to write the column weights. So the column weights are entered as 64, 32, 0, 0, 4, 0, 0 for various bits B6, B5, B4, B3, B2, B1 and B0. As the next step, find sum of elements in the fourth row. So we will get 64 plus 32 plus 4, that is equal to 100. Thanks for watching Circuits Analytica. Enjoy learning. Please comment, like, share and subscribe our channel.